demonstrate how to conduct the molar volume of hydrogen experiment. And in order to do this experiment, you will need a gas collecting tube known as a UVometer, a jug that is about 3/4 full of tap water. You're going to need about 40 milliliters of 6 molar hydrochloric acid, a set of tongs. You will need 3 strips of magnesium metal, a cork that has a loop at the end, and a small square of sandpaper. Each strip of magnesium needs to have a mass between 40 and 45 milligrams, and we can't tell you exactly how long that strip would need to be, but you can see for this strip it was about 2.5 centimeters. Because each lot of magnesium has a slightly different thickness, your strip might end up being a little bit shorter than this or a little bit longer than this. What you can see on this piece of magnesium is that it's not completely shiny, so that black film that you're seeing is a magnesium oxide layer. And when you want to sand the magnesiums, try to get some of that oxide off. You're not going to be able to take off all of it, but take off what you can. So in order to remove the oxide layer, you just take a small square of sandpaper and just lightly sand the magnesium strip. And after you're done sanding, go ahead and grab a Kimlite to remove any remaining residue. And then you'll have to take this strip back to the balance to get the final mass before you start the experiment. After you have the mass of your magnesium ribbon, you're going to take your first piece and you're going to secure it to this cork. So the cork has a loop at the narrow end of the cork, and what you want to do is fold the ribbon in such a way so that it's not going to come off prematurely during the experiment. So this is just a close-up of what the cork looks like once the magnesium ribbon is attached. And I'm just going to warn you to be careful when you're putting the ribbon on, because they can be fairly brittle, and so if you fold them too tightly, if you pinch them, they will tend to snap, and then you have to go back and weigh out a new piece. So the next step is to add the hydrochloric acid and water to the UVometer tube. But before you add anything, I'd recommend putting your jug right underneath the UVometer. This way, if you overflow it all, any liquid will be caught in the jug. So we just add to the position of funnel. Go ahead and add hydrochloric acid. And again, it's just that you need about approximately 10 milliliters of hydrochloric acid, because your hydrochloric acid is in excess. So if you have a little bit more or a little bit less, it won't affect the experiment. And then you can go ahead and remove the funnel, and you're going to fill the UVometer tube all the way to the top, and you're going to fill it slowly so that you don't mix the acid with the water prematurely. And you're going to fill it all the way to the top, and until the water actually might even overflow a little bit, and that's okay, so you put the jug there to catch any liquid that would overflow. And once it's full of liquid, you go ahead and take your cork, and you insert it, and you want to press it in firmly, but not so firmly that you won't be able to get it out at the end of the experiment. So at the moment, our magnesium strip is sitting there attached to the cork at the top of the UVometer tube, and the hydrochloric acid, because it's more dense than water, is at the bottom of the UVometer tube. So now what we're going to do is invert the UVometer tube, and when we do that, the acid will begin floating down to the bottom, and when it hits the magnesium ribbon, the reaction will begin. You'll need to position the UVometer tube so that the top of it is below the water level, and you'll be able to see by means of the density gradient, because HCl is more dense than water, you can see these swirly lines that indicate that the hydrochloric acid is actually traveling down to your magnesium ribbon. And as soon as the HCl hits the magnesium, it will start to react. So we're seeing a few bubbles generated already. And as soon as this reaction gets going, it becomes quite vigorous. So you can see here that the reaction is now well underway, and the magnesium ribbon is still attached to the cork. And if at any point that ribbon should become dislodged, it is okay. It's just important to make sure that all the ribbon does react during the course of the experiment. So if you see that anything gets stuck to the walls of the tube, you just need to somehow tip the UVometer so that the ribbon can continue to react. So at this point the reaction is finished because we don't see any more hydrogen gas being generated. So now we want to remove our cork, and it's important that you make sure that you do have the top of the udiometer still below the liquid level, and because if it's not, then all the water is just going to rush out when you pull the cork out. And so then you pull out the cork, just like that, and that's why it's important to make sure that the cork isn't inserted too firmly at the beginning of the experiment, because if it is, sometimes you can't pull out the cork at the end. So in order to perform the calculations for this lab, you will need to know what the pressure is of the hydrogen gas inside the udiometer tube. And unfortunately, we don't have a way to directly measure that. So we have to make an assumption that the pressure inside the udiometer tube is the same as the atmospheric pressure in the room. And in order for this assumption to be valid, what we need to do is to get the water level inside the tube equal to the water level in the bucket. So in order to equate the pressures, we're going to add some water to this bucket, and then we're going to lower the udiometer tube down into the bucket until the water levels are about equal. And just go ahead and fill your first bucket until your water is about 1/2 inch from the top, just so that you will actually be able to take this and carry it to the sink later and dump it out. If it's too full, you're just going to spill. And then you just lower the udiometer until you get the water levels as close to even as you can get them. The final step is to measure the volume of gas contained in the udiometer tube, and like a burette, the udiometer is read to 2 decimal places, and you read to the bottom of the meniscus. So this tube seems to contain about 42.20 milliliters of gas. Once you've taken your volume reading, you can go ahead and raise the udiometer, which will empty the rest of the liquid in the tube. Take your bucket,